Hey guys, welcome to the second lesson on Advanced C# Programming. Today we're going to be talking about indexers. We're going to talk about what is an indexer, why we use indexers, and how we use indexers. Now, note that this video is it's going to probably be pretty short because although indexers can become pretty complicated, I just want to, like all my other videos, I just want to kind of scratch the surface, allow you to understand the fundamentals, and then allow you to really understand the topic so that if you want to go into it more in detail, you can then just look at it online and you'll understand it, and it's just like a matter of syntax. Oh, if I want to do this, then I just gotta do it this way. So that's the only difference. So, but from watching this video, you'll understand what an indexer is and maybe why we use them. So to start off, let's just first talk about a little quickly what an indexer is, specifically in C#. Um, so when we implement an indexer to one of our classes, it allows us to use our class and with it use the index operator. So when we have arrays, I'll just show you an example. Say int my array equals new. I'll say 5, 6, 7, for example. Oops, like this. When I have an array like this, I can access the array with the index operator, which is this square bracket. So I can say like 1 equals 6. So this allows me to access the second element of the array. This is the operator, the index operator. That's what I call it, at least. So implementing an indexer allows us to use this operator with our own custom classes that we create. Now, the first question is, why would we want to implement an indexer or this index operator for our classes? And there could be a number of reasons. Now, this could be if you're starting to mess with creating your own data structures. This is an intro to that. If you want to build custom collection types, and you have an array in the behind the scenes with your class or something, if it's an array-based data structure, then you can implement an indexer to help you with that. Depending on what you want. If you want allow random access to your collection, I mean that's up to you, but that's one way. So we can use indexers if we have an array behind the scenes in our class. That's one way. Another thing we could use it for is, if we just want to be able to use this syntax for our class. So maybe you're not using an array. This is one of the misconceptions of indexers, are that you have to have an array behind the scenes. No, you don't. If you implement an indexer, you could use it for whatever you want. If you had a math class, I mean, you could use an indexer, say, I don't know, that just multiply numbers together or something like that. Like, it doesn't have to be using an array. Now, in this lesson, I'll probably show you with an array, maybe something else, but we'll get to that. So yeah, that's really the main reason. I mean, the biggest reason that people use it is for arrays behind the scenes, but you don't have to use it that way. So like one class, I don't know if you're familiar with it. I'm not really gonna teach it. Is a list that Microsoft made for us. It's a generic list that we can create. I'm not gonna create it, but pretty much a list is just like an array. It's almost like an array, but it can grow in size and things like that. And that's just manipulating the array behind the scenes. But this has an indexer if I create a list. So Microsoft, when they created the list, they implemented an indexer to it, and that allows it to work. Okay, so yeah. This list class implements an indexer. Actually, why not? Let me just show you really fast that it does. So let's say I had int my list equals new. So this is how you create. Don't worry about this if you don't know what a list is or whatever. My list.add, let's say 5. So I add something, but now I can go my list and see I have an indexer now. I could use this if I wanted to. I don't have to. I could say my list 5 equals 6 or something like that. So I can access the elements of the array behind the scenes like this using an indexer. Because whoever created this class implemented an indexer with it. This is the indexer part right here. Although I don't have to, like, if I'm building a data structure like this list and I'm creating it, you get to ask yourself these questions. Do I want an indexer? Do I need an indexer? I mean, in this particular instance, they did. But let's say if I didn't want an indexer and I didn't want to allow random access, I don't know, I could implement an iterator or an enumerator, and that could allow people to iterate over my elements of my array and things like that. But there's all different options, all different questions you ask yourself when you're building this. But I'm just here to show you what an indexer is. However, like I said, you don't have to use an indexer when you have an array behind the scenes. You can use it for anything, and I'll show you that. But first, let's just go ahead and we're just gonna mess with the indexer a little bit. So I'm gonna create a new class. I'm gonna create a student class. I tend to do that a lot. I don't know why. And this class is gonna be standard. It's gonna have a couple things, but I'm gonna put an array in it. And the array is going to hold the students, let's say like the last 5 grades or something like that. So let's start off with, let's just make a couple things to make a name, an ID, a constructor, and then we'll make the array. So let's first just go, we'll make them into properties. So let's go public, first let's do the name of the student. So public string name, get set, public int ID, get set. Let's do a constructor, public student, string n int I. This dot name equals n, and this dot ID equals I. So there's my constructor, my two things, and then I'm gonna create a an array. So let's go. Now, I'm not going to make this array public, right? I'm going to make this array private because the array, this is all a hypothetical situation, but if I was building like a data structure or something, the array would be behind the scenes. That would be the spine of the class. So I'm going to make this array private. I'm going to say private. I want to make it int. It maybe be more practical if it was a double. It doesn't really matter. Private int array. I want to say my scores. Yeah. So there's my private int array behind the scenes. Okay, so now that I have that, let's go ahead and instantiate the array inside of the constructor. So I'm going to say this dot my scores equals new int, or new int array, and I'll say it has, I don't know, we'll have 3 grades just for now. So there we go, we did that. Now I want to give values to them each. So I'm going to say this dot my scores sub 0 equals, let's say he got a 65. Let's go 1, 2, a 75, and an 85. So we have 3 grades in our array now. That's behind the scenes, and our constructor, we built it all, and we're good to go. Just to see everything's working, let's go ahead and let's build a function that will show all my elements of my array into the console. So I'm just going to do a standard for loop, less than this dot my scores dot lang I plus plus, and then I'm just going to go console dot write line this dot my scores sub I. So this is just going to display all my values of my array into the console. So just to see it work, before we get into indexers, actually, let's just go ahead and go student s equals new student string Bob, his ID is 50. That's all we need, and we'll do s dot show. And let's run that, and as you can see, we see the 65, 75, and 85. So our array behind the scenes is working so far, and we're showing it. Now we want to implement this indexer to allow people to access the elements of the array using the index operator. So the syntax of this is pretty basic. Let's go here, and I'll do it right here. The syntax is first the public keyword, because we need, or the public access modifier, so it's accessible by everyone. Then the return type, so our array is going to be returning an int, so we'll say int. Then it's the this keyword. That's the only thing that's different. We say this, and then next to this we have our index. So we're going to say what our index is. So an index doesn't have to be integer based, right? Even though arrays use an integer based index, it doesn't have to be that way, because like I said before, your indexer doesn't need to use an array behind the scenes. But our array is an int index base, so I'm going to say int index like that. Then my blocks. Now inside my blocks, this is very similar to a property. It's going to have get and set accessors that allow us to get when they're getting and when they're setting. But yeah, before we get into that, this is the syntax. So this is our return type, and then this is what they're going to be passing in the index operator. So inside the square brackets, they're going to be passing in an int. And I did that way is because my array is integer, it returns an integer, and its index is an integer base. So that's why, so everything works there. That's why I'm going to do it that way. Okay, so inside of this, let's first set up the get. Now the get is going to be when they're trying to retrieve data from the array using the indexer. So the first thing we're going to do is we need to make sure that the index that they're passing in is valid, right? We need to make sure that it's 1a greater than 0, because we don't have an array that's less than 0, and we need to make sure that it's not greater than the length, or greater than or equal to the length. So the reason why we have to do these checks and then it doesn't do it by itself is because, once again, I don't need to use this with an array. I could use this for anything. I could use it if I wanted to multiply two numbers together if I wanted to, because you can have multi-indexes because there's multi-dimensional arrays in this world. So, but I don't know if I'm going to get into that. But yeah, so I can do anything I want. So we need to put in the constraints for our specific case. So the first constraint I'm going to use is if the index is greater than or equal to 0. Actually, I'll do it with an n. So that's the first check I need to do. And the second check I need to do is I need to make sure that it's less than length. So then I'll just go if n index is less than what am I talking? This dot my scores dot length. So I'm checking that if the index is greater than 0 and the index is less than the length. If that is, then it passed the check, and then I can go ahead and try to get a value or something like that. In this case, I'm going to say else. If it's not that, I could do anything I want. I could flag something saying that there was an error. I could write an error message. I could do anything I wanted. But in this case, I'm just going to return a -1. And by returning a -1, it usually gets a -1 back. That just means that that index didn't exist, blah, blah, blah. Something, I don't know. It doesn't really matter. In this case, we're just learning the fundamentals here. We're not actually building a program. So now that I have my check, now I can, in this part, if the check is good, I'm going to return the value that's stored in that index. So I'm going to return this dot my scores sub index. Whatever they pass into the index, I'm going to go into my array behind the scenes, get the value of that, and return it back to the caller. So this is the get accessor of the indexer. Now we need to set up the set. Now, if I don't want them to be able to set, I could just omit it and not allow them to set it. I can mark it private to set. I could do all the same things that I could do with the property. But I want them to be able to set it in this case, so I'm going to set up my set accessor. And the set is going to be the same thing. We're going to be doing the standard check right here. I'm going to have to modify this because I need to check that the values are okay. But in this case, I'm not going to be returning anything. I'm going to be setting. So I'm going to say this dot my scores sub index equals whatever value that they passed in. So value. This is the same syntax of a property because this is pretty much a property. So that now we set the value, and else I'm not going to return anything here. Normally in this case, I'd have to like set a flag or something. I don't know. So I'm not going to do anything. So if they don't pass in a good value, I'm not going to do anything, so it didn't work. So this is our basic indexer. It's set up where it does its constraint checks. If they're getting, it returns the value of whatever index they're looking for. And if they're trying to set it, then I set the value of whatever value they passed in. Now we have that, now we can go ahead and use it now. So we can go S, and notice how we have an indexer now. I can use my index operator to access the indexers. If I were to comment this out and try this now, look, nothing happens. I don't have an indexer. When I hit S index, nothing shows up. But when I have that commented in and I hit it, bam, it says int index, and now I can use an index. So I'm gonna say first console.writeLine. Let's go S0. I want to get the value of what's ever stored in the first index. So when I run that, we see 65. Okay, that's cool. Let's go ahead and set it first. And now let's go S sub 0 equals 1,000. This is just so we can see the value change. And now we run it, and now we see 1,000. So by doing this, we can see that our indexer get and set are working perfectly. Let's say if I wanted to do 5 like this and try to run it now, we're going to see the 65 because how we programmed it. If 5 is out of the range of my array, so it can detect that by this if statement, and then it just doesn't set anything. So if I didn't put this here, watch, if I comment this out and run it now it's going to throw an exception and crash because index is out of the range. Because it's trying to access the 5th element of an array by doing this syntax, and our array is only 3 elements long. So this little if statement protects us. That's what this if statement's for. Once again, I'll run it again, and there we have it. So yeah, this is the basic syntax of an indexer. And I mean, this is pretty much why people use indexers like this, to allow it. I mean, if you think about it, we would have to implement more variables and things like that if we want to like iterate it with a for loop out here, because we need to know how long it is, so we can make variables and things like that. But I mean, if we're building a new data structure, an indexer is useful. I mean, depending on what we want to do, indexers can be useful. Although, granted, I don't use them that often. There aren't really that many times I do it, but it's good. It's a tool. It's another tool in your toolbox, and they can be useful. I mean, they're really mostly useful for building data structures. But like I said, they can be used with other things as well. So before I end this video, because this is pretty much the basics of indexers, I just want to quickly show you that I don't have to use an indexer with an array, hypothetically. So I'm just going to go ahead and do this real fast, just to show you an example. I'm going to go ahead, I'm going to delete all my array stuff. I don't want it anymore. I'm going to take away the set. I don't want the set. Or maybe I'll make it private, I don't know. Okay, but in the get, all I'm going to do is, I'm just going to show you that I don't need an array. For my get in this class, I'm just going to hypothetically, just to show you, this does not make any sense. In reality, this does not make any sense to do. But I'm just going to say, whatever the number they type into the index, I'm just going to go return 5 times the index. So whatever they type in, I'm just going to times it by 5 and then return it back to the caller. So now, anytime I try to get something, if I go like this, S5. So this is going to call the get. I'm getting the value of index 5 here, but in our case, I'm not using an array behind the scenes. I'm just multiplying it by 5 and then returning it. So this will display 25 in the console, and as you can see, boom, we get 25. So once again, this makes no logical sense to do it this way, but there may be some reason that you want to do it like this. This is just to emphasize and bring the point home that you don't need an array behind the scenes to even have an indexer. They just so happen to work good with arrays because arrays also use an int index base. So that's why they just seem to work good with that, but you don't have to. So that's what I want to bring home. The last thing I want to leave you with is that you don't need, you don't have to only have a single indexer. The reason we can have more because there are multi-dimensional arrays. So if we need to access a multi-dimensional array, we need an indexer that can support multi-dimensions. So if I wanted to do that, I can just make my indexer support more indexes by separating this by a comma and going like index 2. So if I had it like this now, I'll take my index 2 and multiply it like this. Now I can go 5, 6. This looks like get 5, 6, but really I'm just multiplying them together, and now we see the 30 here. So that allows us to access multidimensional arrays, or whatever we want. If we want to make a multiplier like this, then that works also. Alright, so that's it for indexers. I hope that if you had any confusion, I helped with indexers. This is pretty basic. Just I wanted you to understand it. Maybe by how I explained it, that would help you. It seems to help some people, which really makes me happy. So that's it. Thanks for watching, and if you enjoyed it, be sure to subscribe and like. And yeah, that's it for now.